Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very simple but fundamental topics about the RCC structure. That is, we have the column in the RCC structure, we have the shear wall in the construction RCC structure. But what is column and what is the difference between RCC and a shear wall? In today's video, we will know about the comparison in between RCC and the shear wall. So stay tuned until the end to get the full information about this. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, that is column and shear wall difference or the comparison. So in any RCC structure, we have column, we have shear wall whenever we're doing the multi-story building or the skyscraper. Okay, so there is a shear wall, there is a column. So why this different structural element that we need to know. So first is need to know what is the definition. So column is the definition is vertical structure element that primarily resist axial load. And what is axial load? That is the compression. So column is the axial and transfer them to the foundation. So that means the column, whenever it is coming, it is the axial load is coming to the column and it is transferring to the foundation. So on the other hand, what is the shear wall? It is also a vertical wall-like structure that resists lateral forces such as wind and earthquake. So this is also vertical member, but the difference is that it will, what are the lateral forces is coming due to wind or the earthquake, the shear wall is resist that lateral and the forces and it is transform them to the foundation. So column is the axial loads of the compression and the shear wall is the lateral loads or the lateral force like wind and seismic that are taking care. So these are the main definition. Another thing, what is the aspect? The primary design to carry compressive load from slab beams and arches. So that is the primary aspect of the column. But what is the primary aspect of the shear wall? That it is primarily designed to resist lateral forces and provide stiffness to the structure if there is any wind load or the seismic load is there. So this shear wall give the protection of the RCC structure. Then shape is typically circular, square, or the rectangular in cross section in the column, but shear wall generally rectangular and extend through multiple floors, and its length is more and width is very less. So it is in rectangular length and in respect to width is length is more. Now, what is the position? Placed at specific interval based on the structural design or to support this. But the shear wall is usually placed at the periphery or the core area of the building. So this is periphery or the core area where first the lateral force will come to counteract the lateral force. It is primarily placed in the core area where the lateral load will be transferred to the load. But the in column, it is positioned in the interval by specific interval based on the structural requirement. Then primary load resistance, that is vertical loads, that is a gravity loads, that is lateral loads already discussed, that is a wind or earthquake, and sometimes axial load also. Then stiffener condition. Stiffness condition is provide stiffness in the vertical direction, preventing buckling or collapse under compression. So what column is doing? It is giving the stiffness between in vertical direction, preventing buckling or the collapse under the compression load. But on the other hand, the shear wall give the stiffness in both vertical and the lateral direction, especially in resisting side sway or the lateral force. So what is doing this is not only the vertical. So what is the side sway is coming due to the earthquake or the wind, that is also taken care by the shear wall. Then cross-sectional area, similar cross-sectional area compared to shear walls. It is a smaller area, but it is a larger cross-sectional area designed to cover the significant floor height and width. So if we are considering about the cross-sectional area, the shear wall cross-sectional area is higher compared to the smaller. What is the use in earthquake zones? Primary design for vertical loads transfer not as efficient in resisting the lateral seismic force. So it is not effective in resisting lateral seismic forces. But shear wall, as we discussed, it is effective or minimizing the displacement during earthquake. So to prevent the earthquake, it is very much important. The important is to play the very much important role shear walls. That is why strategically it is placed in the periphery or in the core area where the seismic or the lateral pressure is more to counteract that lateral force and gives the structural stability of the buildings. So what is the load carrying mechanism? Designed to carry vertical compressive loads with some bending moments. Act as a deep vertical cantilever carrying lateral loads with substance bending and shear resistance. Effect on building layout can be distributed freely based on architectural and structural design requirement, and typically needs to be continuous throughout the building, affecting room layouts and openings. So it is required throughout the building. And what is the thickness and size? Already discussed that relatively thinner, designed for load bearing without impacting unusable space. But sometimes in the industrial building, the column size is also more. But compared to the shear wall, it is much thicker, designed for high shear capacity, may reduce the usable floor spaces. And what is the flexure behavior? It provided limited resistance to lateral forces. Primarily, role is the compressive load transfer. So, in the flexure resistance, there is a limited resistance, but in the high in the compressive load. And shear wall, it's provide excellent flexure and shear resistance for both lateral and the vertical forces. So, it is for the both vertical and lateral force. So, column is primarily for the vertical forces, but shear wall for the vertical as well as the lateral forces. So basically it's take the lateral force like wind and the seismic. Then common uses that used in most types of structure for supporting floors and beams, and used in high-rise building, earthquake-prone areas, and where strong lateral resistance is required. So these are the things about the comparison in between column and shear wall. And in the RCC structure, it is always there in the high-rise structure, the shear wall column. But what is the difference? What is the design parameter? What is the cross-sectional area? What is the flexure behavior? That is everything I discover. I share here, and I hope you find it is useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, I'm waiting for your valuable comment, and from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.